Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back for the first installment on the KT120 monoblocks. And like I explained in the Monday monologue, I think I'm going to build this first one mostly off camera and then go through fabrication and all that stuff on the second one once I've kind of figured out what I'm doing and how I'm going to lay all this stuff out. And I think I'm on a roll here. Got all the fabrication work done on the first channel. Got the tube sockets mounted, got my tube rings mounted, got my tag strips kind of sorted out. Got my Thermionic Labs output transformer with Hammond power and choke painted to match. And somebody said it's got like a stormtrooper look, and I like that. I think it does have a cool kind of that white and black look is unique. I haven't seen another amp that's built like that. And the other thing I've decided is I'm not going to skimp around on any of the parts inside this thing. It's going to be running pretty high voltage, and I'll go over that in the schematic, especially using a fixed bias on a single-ended, which I've never done before. This is going to be a first for me, but good reasons. First, don't want a high wattage cathode resistor sucking away the B+, plus all the heat that's going to make is going to be insane. And there's really no reason not to just run it as a fixed bias amp. Going to be running KT120, got a 5AR4, got a 800 volt power transformer, which after it's rectified with a full wave rectification, probably going to end up with 475 or so across the tube, which is pretty hot, but a KT120 can deal with that. Going to use a 6EJ7 9-pin pentode triode strap to drive the tube. I built my Blue Glow KT88 amp using a pair of these instead of using that, I think it was a 6DJ8, with a dual triode. Used a pentode triode strap to drive it, and they sounded awesome. The other thing is there's a whole slew of these little 9-pin frame grid pentodes that you can roll into this amp that have the same pin out and tune how the amp sounds. I actually ended up using 6JC6A pentodes in mine. Don't know what's going to sound best in this, but think it's going to drive it fine. Again, not going to skimp on the power supply, using a giant film cap 22 UF for the first cap. They're going to have a 600 volt 100 UF and then have a 180 UF 600 volt on the tail end. And then we have this 5 Henry top mounted choke and this 2 Henry that's going to be inside. So should have some really clean DC going to the output tube and the driver tube. Got these really nice output jacks. Got some nice RCA jacks to use. I'm going to be mounting the RCA jack up here. Haven't decided exactly, but it's going to be somewhere, in this kind of area around the input tube, so I can have a really short signal path, like maybe an inch from the RCA jack to the tag strip, so we don't have to deal with any kind of shielded wiring inside it because there's no signal path inside that's this long. So I think that's going to be cool. This is actually the right-hand amp of the pair. The lefty's going to sit here, and it's going to be a mirror of this with the KT120 on the outside. So I'm getting the two hot power tubes away from each other and also keeping the power transformers away from each other, so we don't have crosstalk between or any of that kind of stuff going on. But mainly I wanted to keep these KT120 tubes away from each other. And then the RCA jacks are going to be in the center, and they can just come down the center and then to whatever gear. And so they don't, get in the way or look ugly. draping over the top of everything. They can just be run down the center of the 2 amps. Going to put the speaker jacks on the back. Got a IC connector back here, a fused one, and then we have this Angel Eye power switch here in the front. And then when we're done, we'll put our Skunky logo on the front. Here's the little fixed bias pot. It's got a nut to lock down the adjustment. These are going to go like right over here. And then I thought about putting a meter on it. I think I'd shown you these little LCD meters, and I was going to maybe power them off a 9-volt battery, and I thought about a lot of stuff, but after I started laying the amp out, I just didn't like the way it looked. It just, I don't know, it looked cheap. And so what I decided to do is I'm going to put a test jack, or maybe 2 test jacks here, positive and negative. May just put a positive one and you just pull the negative off one of the bolts holding the transformer down. I haven't decided on that yet, but I'm just going to have a test jack. We hook a meter up to it, and then if I do end up selling these, I may make a little handheld meter thing that you can, plug into there. I don't know. I haven't decided on that yet, but I think test jacks with a potentiometer right here between the rectifier and this makes sense. The other thing that I'm really trying to do with this amp is to make it where it can use a wide variety of tubes. And it's another reason for going with the fixed bias. Even at 450 to 475 volts in EL34, KT66, KT77, 6CA7, I think it's 6550, even a 6L6GC should work. And of course KT88s, and then all the way up to a KT120 should be able to be rolled into this amp and just change the bias accordingly. The other thing that can be done, because it's tube rectified, is we can swap out this 5AR4 for like a 5U4G or something like that that's got more voltage drop or sag across it, and that can lower the voltage down to make it more like EL34 friendly. And then when we're done, I may end up putting a solid state plug-in rectifier thing in here to really jack the voltage up for these KT120s to see how much power I can get out of them. So having a 8-pin socket here for the rectification opens up like a lot of different opportunities for rolling different tubes into this amp and having it running at different power levels. So I think that's a really cool feature. So let me jump in and we'll dive into the schematics, and I'll kind of show you what I'm thinking, at least in the design phase. And some of this is going to change. And a warning like I give on all my videos like this, I don't even have any wiring or this thing powered up yet. So if you want to follow along and like build this as I'm building it, I have no idea what this thing's going to sound like when I'm done. But I have a pretty good idea that it's going to really sound awesome. So let's go look at the schematic. Okay, so let's take a look at the schematic. This is a KT120 single-ended ultralinear amp inspired by a design that Kager posted and made a few modifications to make it, I think, improved and just work better for what I'm trying to do with it. So let's follow the voltage through the amp. We're going to start off with a B plus of 450 volts. Going to come up here, go through the output transformer. First we come out of the 40% ultralinear taps, 1.2K resistor to the screen of the output tube. Then we come off the other side of the output transformer, come up here, go to the plate of the output tube. We're going to tie this screen to the cathode, which you need to do if you're going to run EL34. We have a test point here on the cathode. We have a 10 ohm resistor to act as a shunt for measuring the current across the tube, and then it's grounded. So basically the cathode in this design is grounded. This 10 ohm resistor is going to have no impact on the sound or anything else. It's just a way to measure the voltage, and it also acts as a fuse if we use something small like a 1-watt resistor. In case the tube ever red plates, it'll pop this resistor before it does anything nasty and tears up the output transformer. So the grid of the tube comes through this grid stopper resistor. This is our 100K grid leak resistor, and this is where the negative bias from the bias supply is hooked up, which will probably be somewhere around negative 50 to negative 60 volts. For the driver section, same voltage comes up here. It goes to this RC resistor capacitor filter to decouple it from the output transformer. Then that voltage comes over here. Here's two 75K resistors in parallel that are the plate load resistor. They come up here to the plate of the driver tube. We have two 500 ohm resistors that connect the two screens in this tube to the plate to triode strap it, which is turning this pentode driver tube into a triode. The grid gets a 2K grid stopper, comes over here to the positive of the RCA jack. Here's our 220K grid leak resistor that comes to ground along with the RCA jack ground. Then the cathode is grounded through this red LED, and I'll show you about all that when we get to building the amp. 1.6 volts, and then we're going to adjust this resistor here. Start off with 150K. We're going to adjust it to get 2.8 to 3 volts of bias on this tube, which we may play around with that a little bit just to see how that works out. And then finally we have this 300K shade feedback or local feedback resistor that goes from the plate of the driver tube to the plate of the output tube. And then we have a 0.33 UF coupling cap between the plate of the driver tube and the grid of the output tube. Now you can see Kager's design is very similar. He's got 500 ohm cathode resistor with a 220 UF cap across it, and then you have a 220K grid leak resistor instead of 100K, and that's grounded in his design. So while he's showing a little higher B+, he's got 475 volts here, which in reality we may end up with as well. But in his design, with this 475, you're going to see about 60 volts here on the cathode, and so you're really only putting about 415 volts across the tube, and I want to put more than that. So let's go over why we're using a 6EJ7 driver tube, which I know some of you may have never heard of. Here's all the tubes that can be rolled into that socket that are wired the same way when you triode strap them. And as you can see, there's an insane variety of different tubes that we can pop into this amp and try. And I built an amp using a KT88 tube using a 6EJ7 design, and I ended up using this 6J6A tube. So ignore these pentode numbers because we're not using it as a pentode, we're strapping as a triode. You can see that between this tube and this tube, the 6JC6A has a little more gain, has the same resistance, a little higher wattage dissipation than it can handle, and it can also handle a little higher voltage if we ended up having to play with that to get more drive out of the driver section of the amp. There's also other options. A very popular tube is a D3A, which you can see right here. It's got 75 gain and a little bit lower resistance, but these are stupid expensive to try to find online. So one thing that we may play with if we need more drive is going up here to this 6J52P. It's got 70 gain, and it's got even lower plate resistance than this D3A does. And I bet these are cheap. I haven't looked, but I'll be shocked if they're very expensive tubes. There's also other ones we can play with. If we wanted to have about the same gain, but we wanted to lower the resistance of the tube, we can go with this E280F. And I've got some of these in stock. Got a pile of old TV tubes, and that's what these are, these frame grid pentodes. So let me show you one other thing about this tube. Here's a 6EJ7 frame grid pentode strapped as a triode, and this is the curve. Here's the load line at 30K. Look how even the gaps are between these lines, and that's showing how linear this tube is. That's why this thing sounds so good in an audio amp. So here's the operating point we're looking at, which is a little higher. It's 2.8 to 3 volts than what they've picked out, which is 2.5. But you can still see you can get some massive voltage swing out of this tube, and it's super linear. So that's why we're using this tube. So let's take a look at the power supply, which is going to be fairly simple as well. We've got this Hammond 375X transformer, and you're thinking, wow, 135 milliamps, that's not going to be enough for a KT120. That's one reason we're building them as monoblocks, so we don't have to get some monster transformer, and then we don't have to worry about exceeding the rating of a 5AR4. So this is our 5AR4 tube. We got a 3 amp winding on the 5 volt, which will allow us to use any rectifier we want to use. If we want to lower the B+, we can pop in like a 5U4GB, and it's got more voltage drop across it, which would lower the B+ for maybe a different type of output tube we want to try to run. Then we have the center tap. It's grounded. The output of the rectification goes to this 22 UF 630 volt film cap. Then we have this Hammond top-mounted 193H. It's 5 Henrys with 65 ohms of DC resistance. You can handle 200 milliamps. Both these chokes can, so chokes aren't going to be a problem. Then we're going to have a 100 UF 600 volts. Decided to go kind of overkill on the voltage on the capacitor, just so they're kind of coasting along, and we don't have to worry about them ever giving a problem. Then we have this 2 Henry 47 DC resistance choke that's mounted inside the amp. And again, we have a 180 UF 600 volt cap here right before the output of the B+. We've got our winding here for 6.3 volt tube filaments. It can do 5 amps. Given we're only driving those 2 tubes, not going to have any issues there. Transformer should run nice and cool. We've also got a 50 volt tap on this to pull off for our bias supply. And there's 2 different options on the bias supply, and I have a feeling I'm going to have to go with the second. But here's the simple half-wave bias supply. We have a diode, filtering capacitor, then we have a 10K pot, we have a 10K resistor on this end, and that keeps us from ever turning the bias down to like 0 by accident and making the tube run away. We also have this 100K resistor here across the top to the wiper, so that if the wiper ever goes bad in this pot, this 100K will just put full voltage on the negative bias to the grid, and it'll just turn the tube off instead of it red plating and causing a nightmare. And then we've got another cap here. I'm probably going to use 100 UF. These have 10 UF written in here. I need to change that in the diagram. But what I think I'm going to end up having to use is this design here, which is a half-wave voltage doubler. And so you have a 100 UF cap here, you have one diode, a second diode, you have another filtering cap here, then we have the bias pot, we have this resistor. This resistance acts like an RC filter to smooth out the DC, and then we end up with 2x of the bias voltage, which is probably what we're going to need for the KT120. So that's basically what we're going to be doing. So let me show you what the inside of the amp looks like and how we're going to wire that up. Okay, we're going to take a quick look inside the amp, and there's not a whole lot to wiring this up, but we do need to be attentive to where we put components. So first thing we have is this big cap, and it's probably going to be, get a strap and mount this guy back here, maybe even kind of over in this corner a little bit. Have one of these leads come up here to the positive of the rectifier. Then the other side will go to the ground. So the next thing we got to do is mount this choke here in the back panel. And then one of the leads is going to come up here to the same B plus off the rectifier that this cap is. Then the other side of that choke is going to go to the 100 UF cap, which is likely going to sit over here on this screw. And then the last one is the 180 UF cap, and it'll sit right next to it, tapped off this screw. These two wires go to the choke on the top side, and then this other terminal on the cap, one is positive, one's negative on each of those, and the second cap will be the final filtered B+, which may bring it over here, may just pull it straight up to this tag strip up here where the tubes are. Then we'll have a resistor and a capacitor that then feed the input tube tag strip. And then kind of laid out where I'm going to put all the resistors and all that. A 5-terminal tag strip will be fine. This is going to be our star ground point. Probably make these two tags grounds. So we'll pull the center tap for the 6.3 volt over here. Then I'm going to solder a couple of wires to these stranded wires that come out of the transformer, some solid core ones, and going to run the 6.3 volt inside this little rail. It's going to come up here, come over to the KT120 or the output tube, these two terminals, then come back, go up, over, and across, and then go to these two end terminals for the heaters on that to keep the AC heaters far away from the signal wiring as we can. The RCA jack's going to sit over here in this area. Then just go short path right to this tag strip with a couple of wires. These are the high voltage AC. They're going to come over here. And I know this looks like a twisted mess, but once we start hooking some of this up, it'll, chill out. These two come over to the rectifier tube. These two yellow wires are the 5 volt heaters for the rectifier tube. They also get twisted up, hooked up to the rectifier tube. And then this center tap and this center tap will both come over to our star ground point where all the capacitors get grounded. The last thing we have to deal with is the bias voltage. This is our 50 volt tap. It's going to come over here to this tag strip, hook it up to here, and then I'll have to see. I may have to put a longer tag strip here. We'll figure that out once we start getting everything wired up. These are speaker outputs from the output transformer. They'll just run here to the back panel of the amplifier. And then these 3 wires here, one of them goes to the B+, one of them goes to the plate, and then one of them goes to the screen for the ultralinear tap. We also have the power switch right here in the front, and it's going to just run along this rail here and come back to the IEC connector. And then finally, we have the primary wiring for the power transformer. You can either wire it in series like this, and that's for 240 volts, or you can wire them in parallel like this for 120 volts. So this looks like a good place to wrap up this video. Well, I hope that kind of explains where we're going with this, and this is a project I'm pretty excited about. I think that, this is something pretty unique. I looked on the internet and only saw a couple of single-ended KT120 amps, and the cheapest one I saw was, I think, $4,700. So this is some pretty high-end stuff we're building here, and that's why I'm not cheaping out. We're going to be using Mundorf, Nikon. All the voltages are going to be way over what we're needing to ensure that this thing has a super long life and that it really sounds good. Plus, what I like about this amp is it's got a very direct signal path. There's just not a lot of stuff in the signal path. There's a few resistors and one coupling cap, and that's it. And so it really should have a nice clean sound. And I've only heard good things about these KT120 tubes. Now, I know some of y'all are saying, it's like, where do you even find KT120 tubes? And when you do find them, they're super expensive. Well, they're not any more than what a really nice 300B tube costs. And that's kind of what you got to pay to play. I mean, right now, there's no cheap tubes from Tungsol out of Russia. That's not happening. And so the idea was that if you want to build something like this, and maybe you can't afford to put KT120 tubes in it right now, you could put some much easier to find tubes like KT88s in it and just set the bias for those. So anyway, I hope you're as excited about this project as I am. And I think this thing looks amazing. These chassis weren't cheap, and it was a little intimidating to start drilling into them, but I finally broke out the drill and started drilling holes, and I think it turned out really nice. I mean, let me show you the side view. Looks like that. And I think that's let me move this. That's going to be sitting about right there, I think. And then I just, maybe put the adjuster right here where it's, not too close to the tubes, and this is kind of the outboard side of the amp. And then put the test jacks here where you could plug them in and kind of drape the wires over the output transformer, set the meter in the front, and then you can adjust the bias like that. And then, like I said, the other one's going to sit over here like the mirror of it. So anyway, hope y'all are liking my Stormtrooper amp or whatever. Why don't y'all name it? What do y'all think this thing should be called? Put in your comments a cool name that you think I ought to name this thing. So I did have to order some parts. They should be here in about a week, so might be another week or a week and a half before you see another really episode on this deal. And like I said, once I get done with this first one, we'll do a much more detailed video series on the fabrication and building of the next one. So until then, have a nice day.